Hi and welcome back to the channel. Today we are making a power supply for an amplifier. This power supply will have a main section which will power the amplifier and a subsection which will power the USB of that amplifier, USB module, MP3 module of that amplifier. So first we will make a simple plan on a simple white paper. We need two AC inputs. So we are planning to have two AC inputs. One is 20 volts and other is 9 volt. Because our USB module will be working between 8 volt, 9 volt to 12 volt, we are using a 9 volt input. And here is the bridge rectifier. We are using this. This is a 15 ampere bridge rectifier. We will be using this for rectifying our main section, the amplifier section. So we will just draw the pins. You can see that first pin is positive and the other two pins are AC and the last pin is negative. We will connect the inputs to the AC pin of the bridge rectifier. Now we require some capacitors to smoothen out the rectified AC. So we will be using 4700 UF capacitor, two of them. So we'll plan to place that here and we'll just make space for two of them. We have to plan like this because otherwise sometimes there will be no space left after placing the components on the main board. So we will just plan it on a paper, that will be easy. And we will have outputs. We will use spade clips for that, for a positive and negative outs. You can see from the positive it comes to the connection comes to the capacitor positive, and from negative comes to the capacitor negative and goes to the output pins. Similarly, we will use another bridge rectifier. This one is 1.5 ampere bridge rectifier because our USB module needs less than 500 milliampere power. So this will be sufficient. So we will place this one on that. I will just plan the pins. Here also we require a capacitor to filter the output. So we will be using a 470 UF or 1000 UF capacitor here. So we are using a 470 UF 25 volt capacitor because the rectified voltage will be under 25. So this side we are using 4700 UF. We will also use a 100 NF capacitor for filtering the high frequency components. If there is any interference, electrical interference, anything, we will use a 100 NF capacitor in the other section also, in the USB section also. So this will be our plan. We may take out another AC out for the speaker protection circuit or a delay circuit. In this case we are using a delay circuit. If you are using a speaker protection circuit also, you can use that, the same thing. To fix the spade connectors, we may need to drill it. If you have got any drill, you can drill it and fix the spade connectors. These are called PCB spades. PCB spades are available everywhere. You can find it in any electronic shop or online also. You can it will be you can search for 6mm spades. And for the output also we require some holes. So we will make the holes here and we will fix the spades here. So our fixing of the spades are finished. So we have the input and output connections ready. Now we will assemble the rest of the components. Now we will fix the bridge rectifier. As we have told earlier, we are using a 15 ampere bridge rectifier. You can search for 15 ampere bridge rectifier and you will find it. And we'll just check if we can push it through. Sometimes with some kind of vero boards, you may require to drill again, but here no problem is there. It's sliding in smoothly. Now we will fix the capacitors just like we planned earlier. We will fix the capacitors. Just check the orientation of the thing, the positive and negative pins. The positive pin should go to the left section where the positive section of the bridge rectifier is. Now you can bend the leads and you can connect it to the bridge rectifier directly. Now we will put the second capacitor. we are using both 4700 UF capacitors. Since we are dealing under 35 volts, our voltage will be roughly around 28 volts. We are using 35 volt capacitors, and we will use this 100 NF capacitor to filter out the unwanted frequencies. There may be some contaminations and unwanted frequencies there, so we'll use this one to rectify it. So you can fix it like this. Similarly, you can do the other section, the USB section. For that section, we require to fix our bridge rectifier and our capacitor. Just check the connections. We have to connect it properly. From bridge rectifiers positive to capacitor positive, from bridge rectifiers negative section to capacitor's negative section. The AC section should go to the input section. So now we will fix the 100 NF capacitors. So it's almost ready. Once we fix the components, we can bend the leads and directly connect to the other connections, and make sure that you are connecting to the right pins. You check your diagram and make sure that you are connecting the leads to the right pins, and you can solder them, and you can finish this project. It is as simple as that. This is our output. From this we will take the output of this USB section that will directly go to the USB module. So our power supply is ready. We have got a high voltage section where it will rectify the power for our amplifier, and the other subsection which will rectify the power for our USB module. This will be sufficient for our amplifier with 2 power supplies, but I thought that let me add a regulator IC, regulator chip for regulating the 12 volt power supply. There may be some voltage fluctuation or something, and if a high voltage goes to our USB module, there's a high chance that it goes bad. So we will fix a very simple LM7812 IC, which is very cheap, and you can simply fix it. And I also fixed a heatsink. You always fix a heatsink for such ICs. So this is our transformer. This transformer gives 2 secondaries. One is 20 volt and other is 9 volt. We will check how much power we are getting. Is the voltage is okay? First we will measure the input voltage. So we are getting around 21.8 or 22 volt. Actually the transformer is 20 volts, but we are getting slightly higher because of the higher input level, because I am getting 240 volts here. Transformer is for 20 volts. So output we are getting 29 volts. So we are getting roughly the correct voltage under 30, and here we are getting around 9.94 volts, and after rectification we are getting around what is that, 11.50. It's almost in the range. We have to give about 12 volt to get around 12 volt to get 12 volt output. So this is okay. 11.50 is okay, because we are giving only 9 volts input. So our circuit is working perfectly. So we'll make an amplifier with this. If you want to see the making of that amplifier, please subscribe to our channel. So thanks for watching, and good day to you.